will be recorded. You see the recording in progress. So let me briefly introduce our speakers. I don't want to take too much of their time. And they'll present, and there will also be the usual time for questions, either typed into the chat box or people can unmute and talk. Our first speaker is Dr. Ruchi Thanawala, who joined OHSU as an assistant professor of surgery in the section of thoracic surgery in the Department of Surgery last year. Another person who I've talked to a lot, but I don't think we've actually ever met in person due to the pandemic, but hopefully that'll change in the not too distant future. She's trained as a general surgeon. She did her general surgery training at University of Massachusetts Bay State Medical Center, and then a fellowship in cardiothoracic surgery at the University of Iowa. And during her research time in her residency and fellowship, carried out work in surgical education and informatics. And in fact, she actually has a Master of Science in Health Informatics from Northwestern University. She will be joined in the talk by her husband, who she also collaborates with professionally, Dr. Jonathan Jesneck. And he is the CTO at a company called Firefly, where he coordinates building of HIPAA-compliant infrastructure and analytics of surgical procedures and procedural training. He was a postdoctoral fellow at the Broad Institute of Harvard and MIT and Dana-Farber Cancer Institute at Harvard Medical School, and developed an analysis system for early stage discovery of pharmaceuticals using gene expression-based high throughput screening. He has a PhD in biomedical engineering and also master's degrees in statistics and computational biology and bioinformatics, all from Duke University. So again, they will present their talk and hopefully leave a little bit of time for questions. And so take it away, Dr. Thanawala.
Okay, well, thank you again for giving us the chance to present. So as Dr. Hirsch mentioned, you know, what a lot of our work focuses on is combining these data silos that exist in surgical education. There we go. Dr. Hirsch already kindly introduced us. I'm trained in surgery, you know, general surgery, cardiothoracic surgery. Most importantly, I have not yet forgotten what it was like to be a surgery resident and to have your entire educational experience very fragmented. With information existing in the electronic health record, you have to log your cases, you have to then get evaluations, and it's all piecemeal. And as a learner, you're trying to bring all of this together. This problem exists hundreds and thousands of fold for all trainees. I also have completed a fellowship in surgical education, so Jonathan and I, working together, decided that we would try to combine our experience research in, we're passionate about innovation and invention into the space of education informatics, which is a growing field. For disclosures, Jonathan and I are co-founders of Firefly, which is a company that we started out of the platform where research originated and continues. We own intellectual property in the form of patents. So training surgeons is hard. Training doctors is complicated, because we talk about how competency must exist. You know, we must find a way to create competent doctors who will go out into practice. But what happens when we overlay electronic health records with handwritten evaluation tools, with informal feedback that happens verbally, and that isn't centralized anywhere? So when it goes back to actually retrieving that information, it's very hard to. And we're asking humans in the form of residents, you know, faculty, program directors, to manually enter in information, and we get always the begrudging comment of, doesn't that information exist somewhere? And it does. So by pulling and uniting a lot of this information, we're trying to bring quantitative analytics to the training of surgeons and doctors. And we'll go through. Sorry, we have a lot of data to get through, but hopefully will be of interest. So our approach, we decided that we would tackle this project in a big way, is we would actually build a platform, which is what we have. We have a live platform in use that we have coded and developed ourselves. So we started, and our goal was to build this foundational data bank for surgical education research, and at the same time to provide real-time solutions to the challenges such as operative case logs. To provide context, a resident and surgeons must keep a log of all the operations they do for credentialing. For a resident, it's required for graduation. For faculty, it's required for your maintenance of certification and your board certification. Operative and clinical evaluations. That's obvious to any person that's trained in the medical field, that ongoing evaluations are necessary to assess when a person is ready to graduate. And the key thing is to identify outliers, identify people who are struggling, and integrating everything together in a way where we're able to use the information, create hypotheses, build solutions, and have it all feedback in the real time. And a key aspect of the design of this data bank was a user interface that optimizes the workflow for each participant, from resident and attending to program director and residency coordinator. A lot of work has been done in this space where an intervention has been interjected in the middle of the workflow that doesn't always make sense to someone, as in, you know, you've done this operation with a resident, and like 2 weeks later, you'll get an email that you need to complete an evaluation. That's outside of the cognitive normal workflow of that faculty member to do the evaluation. Understandably, when you have something that's not really directed to the workflow, compliance decreases. The validity and accuracy of the information decreases. So what we did is really try to focus on where we could have the highest impact in the workflow and limit the human interaction at the critical points. And what we found is that when we integrate all the siloed information, and these siloed databases that we're talking about are the operative schedules from the electronic health record. The ACGME has a case logging database. MedHub, which is used, New Innovations, contains a lot of the evaluative data on the residents. And if we integrate them into one platform, as we've been able to do, the results are not just additive, they're actually more multiplicative. And what we're able to do is, when we have a very large database, is actually use a high throughput data mining analysis techniques and generate hypotheses while testing them almost and iterating on them as the process continues. So, sorry about that. To kind of step back, you know, we're talking about surgical education, and we're talking about, you know, aggregating a large amount of data. So we just like to talk about, you know, big data, hypothesis discovery, surgical education in the context of the basic science world, such as cancer biology. So in these worlds, we've moved away from the very traditional linear pathway of knowledge discovery, of gene identification, which, you know, traditionally had started out with the genetic mapping and then on to clinical implications. And what really revolutionized cancer biology was technology and the development of better tools. And the paradigm then became focused on dual fronts. And what I mean by this is, by having the ability to test thousands of genes instead of one gene, we were able to develop hypotheses worthy of deeper analysis and make the scientific process more comprehensive, efficient, and iterative. And what we've done is actually applied this concept to surgical education, and we're able to identify large patterns and questions that we were not yet able to know we were or worthy of asking and solving until we looked at the bigger picture. So what we did is, at the center sits this platform that we have custom built, and it connects to the hospital. From the hospital, we get the surgical schedule. It connects bidirectionally to the attendings and the residents. It connects bidirectionally to case logging databases such as the ACGME, the American College of Surgery Surgeon-Specific Registry, which is the registry that faculty members have to keep, mastery of breast surgery, and real-time analytics. So what have we discovered? We've discovered that the problem that we sought out to fix in our one institution actually is a problem at many institutions. We started our platform in October of 2016, and it really started out of research. because we were really trying to solve a problem that every single resident and program director felt a pain for, and that existed everywhere. So we've grown to 23 institutions, 15 departments, 9 training programs. We have over 4,000 users and about 450 surgical residents that are using it. And we've helped log over 50,000 cases and 10,000 evaluations. And this is not to pat us on the back at all. This is more to show how if we pay attention to the workflow and we unite data in a way, we're able to solve big problems pretty quickly. So the surgical education landscape. This is some of the work what we've done where we've amassed this large amount of information. And I know some of this gets to be very niche, but if you'll just bear with me, I'll kind of, I'll try to contextualize it in a way that matters. So when we're able to unite anonymized data across institutions that generally locked into, if we would like to consider an institution as a data silo, which it really is, and the case logs, that unification hasn't existed in a centralized platform, not only just within an institution, but across institutions. We're able to look at things like this genetic map. What this map looks at is what is the variation in the training experience from institution to institution. And within a training program, specifically relevant to OHSU, where the general surgery department, the residents may rotate at up to 9 different hospitals. We're trying to identify when a resident becomes competent. We start to recognize that, the case mix they're exposed to actually may have a significant impact on what is their maximum ability to, or what does the environment allow for their maximum competency. So if someone is at a low volume institution for a certain operation and you have a new faculty member that started there, that resident doesn't have the same opportunity that another resident at a high volume institution with a senior faculty does. But unless we capture that information, overlay that on evaluation data, how would we know that? Other than using our current, what I consider very archaic methods of just basing it on the number of operations a resident has done. And relying on their case logs means that they're being truthful in, how much of the operation they really did. But information exists that can help us to better define how successful they can really be. Additionally, as we're trying to do studies to look at, how residents are performing across institutions, if we have a profile and we can compare programs to each other, we could actually support better randomized controlled trials with a better matching between programs. And then we can assess, how does the training profile change potentially as teaching faculty change, other variables change? The interesting thing is this information exists. All we've done is connect segregated information, and we can discover so many different things. This is a network plot that we created. And what we did this off of is actually looking at information as simple as the operative schedule pulled into the platform. So OR schedules include the operation that's being performed and all the participants in it, from faculty members to the residents that are participating. And what we did is we looked at how often pairings happened between faculty members and residents. The significance of this is that senior residents are known to often operate with senior surgeons because you're trying to refine those last bits of your skills before you graduate. Junior residents usually get assigned to someone else because they don't have a lot of power in the system, and we're trying to focus on what their learning needs are at that time. But if we identify these pairings that may be happening in a way that is not intentional and not captured, understood, or calculated, then does this actually have an influence on how a resident's learning? So if you have a resident that is struggling and they're working with an attending that perhaps that they don't work well together, or the resident is struggling to understand how to do an operation based on the language that attending's using, could we adjust the pairing by identifying a faculty member with which a resident learns at a steeper rate and assess how that happens? Unless we look at how these relationships actually already exist, we may not be able to capitalize on that opportunity. So this is a system level, view of resident operative performance. And what we're looking at here is this is pulling on the reference of the gene expressions. And this is looking at the operative evaluation data, similar to a microarray chip, with each column representing the individual resident and each row representing an attending. And what we're trying to do is to identify patterns of where a resident is getting more and more autonomy. And does that match with certain attendings? Are there certain pairings? Are there certain attendings that are very good at teaching? And this can be broken down to a specific operation, which is what we do. And this is useful for faculty development. Again, this is information that exists. We're just applying a lot of data analytics tools to make this available and visible for use. This is another plot. This is a heat map that we've used for operative skills data across institutions. And this is to identify cohorts of residents and how they're performing. So are there certain characteristics of residents that may be performing low that actually follows a national trend? And can we actually create interventions and remediation plans and measure the effect at a large scale? Can we identify why one group of residents is performing in a certain way compared to their peers at an institution? And what if we share this across institutions? We're able to do this when we free the data from the confines of the silos. Another thing that we're doing, and this is getting into the nitty-gritty of surgery, but from the informatics level, let's think about how we can reuse components of information. So operations are done, but operations really consist of bits and pieces. So they're common components, as in, a simpler example of a procedure is central line placement. So there's an ultrasound use, to identify, say you're putting in a right-sided IJ central line. We use the ultrasound to identify the internal jugular artery or vein. Similarly, in the operating room, a resident would do that for a port placement for chemotherapy. But instead of the current model, where we actually look at evaluating a resident on an operation, what if we could break down the components? And we build a database that can support the components, and we actually start to map over the crossover between the components across operations. And now we actually start to build the learning curves for the components, and then identify how they're progressing in their learning of the component. What we can do is start to map out at a more granular level how a resident is obtaining skill. And the concept of reusing information is very natural to us in informatics, but it hasn't yet been done in surgical education. This is actually probably one of the biggest spaces of our current ongoing research, is to deconstruct all of the operations that exist in general surgery that are core operations. We've already done this in cardiothoracic surgery. And the crossover and transferability of components between operations is tremendous. And we're hoping that over time, as we get enough cases, we'll be able to alter the paradigm of identifying competency in operation to identifying competency in case components and constructing an operation from that. What was necessary for us to do this was to build the infrastructure to support that. And we'll go through our slides on that shortly. Using these case components, we're able to break down how a resident is performing compared to their peers at the institution and at the national level. Again, by removing the confines of the institution, residents generally aren't able to get feedback on how they're comparing to their peers at a national level. But it matters all of a sudden when you're applying for your fellowship positions and you're applying for faculty positions. So having an awareness of how you are learning compared to your peers matters. Additionally, the phase that I'm in, where it's my transition to practice as I finished fellowship, late last year, and then I'm starting my faculty position, that knowing where I am on the learning curve for case components helps senior partners to know where they may need to assist their junior partners. And this is all information. This is just finding a way for everyone to be able to see it and use it. So this is actually, now we're going to move into the solution that we've built, the platform that we've built, and how we actually had to unite systems that don't want to talk. And, we're talking about the stuff, EHR, the goal was to not have to use interfaces and build interfaces. And, that's why a lot of these languages were developed so we could share information, seamlessly, relatively seamlessly, easier than had been. But the example of what we had to do is how interfaces are still important. To first identify as a proof of concept that we have a problem and that we have a solution that can impact the problem, and hopefully over time get these systems to connect to each other instead of having to connect through a platform that we've built. So our platform sits at the center of information that's shared from the hospital in the form of a surgery schedule. It sits, with the systems such as MedHub and new innovations for evals and case reminders, and then connects to educational content. And then lastly, the case logs. And we'll go through each one of these segments and how we actually constructed our interfaces and the impact we've seen from our technology development. So the big picture, and we always try to keep this in mind, is our goal is freeing up, liberating the information, connecting it to the users, and having them utilize it. Having them utilize it is more complicated than the old concept of build it and they will come. That doesn't really apply almost anywhere anymore because people have a lot of options. So the author Pip Colburn I wrote 2016. In 2006, wrote this book called The Change Function. Some of you may know this. What it is the change function is actually like this functional calculation. When you're asking someone to do something new, something that's foreign to them, we have to have an assessment of what their perceived benefit is. Also, what is their current pain? And then what is the perceived pain of adoption? And the key word here is perceived. There's a perception. So the way in which we describe things, the way in which we present information, we ask for interaction is very important. And we've spent a lot of time trying to study and understand the individual workflows of all the different users. We were fortunate because I was a resident. I intimately understood the workflow and the pain points for the resident and for fellows. And we worked very closely with faculty members and program directors to understand their workflow. And then worked with surgical education policymakers to understand the big questions. And we built everything to hoping that we can make things easier so people will participate and we can get better information. So the OR schedule is the first thing that comes into the platform. Using that, a lot of the information is already entered, as in who's doing the case, which residents are participating, the date and the time of the operation. And that's the base information that goes into the case log that's actually been, up to this point, manually entered by the resident. And we'll go through the attrition that happens when you're asking for someone to manually enter in information that already exists in another space. Then, because we know what operations residents are doing, we're able to push evaluations to the faculty members and the residents, which has increased the evaluation completion. Because again, by asking faculty members to manually enter in information, there's another degree of attrition that happens. And then the live analytics that we're able to do, because we have worked on the statistical modeling inbuilt into the platform to share that information back, because people always want value added to everything that they do. And we are data-driven people. Surgical residents are, faculty members are. We like to see how we're performing, especially if we're contributing to a system. And then when we know what people are doing, what if we actually start to connect in libraries of content? And that's one of the aspects of research that we're working on. And Jonathan will go through some of the mapping language that we're doing for that.
Okay. So with that high-level overview, I'll talk about some interesting little pieces of this about how we actually do the data integration, the data transformation, and standardization. And just as a small plug, that we're starting our research lab here. If any of this looks interesting to any PhD students or any faculty or interested in collaborating, we would love to hear from you. Okay. So for this section, I'll talk about was probably the simplest part of the system, which is just sharing the surgery schedule from the hospital's EHR system into the platform. But as you'll see, even this small part of who is doing what procedure where gets complicated fast. So to let you understand how this works in the real world of the resident education is that you have the cases assigned in the EHR system, and there's usually, depending on the how the data is entered and where and who has responsibilities for what, there's varying degrees of trustworthiness in that data, especially with case assignments and procedural details. And then a lot of times the residents have their own flavor of that schedule, either written out with handwritten notes in their notebook about what cases they've done, or maybe in a spreadsheet in their laptop back home. And then we've tried to clean that up in a schedule that we have in our system that acts as a layer in between these. And then there's external case log systems such as the ACGME case repository that the residents need to report their cases to for graduation credit. So a lot of times this agrees somewhat, but not exactly with the other flavors of the schedule. So we had to build a reconciling system, first of all, just to get the base data to work with, about how to know what cases actually took place, didn't get canceled, didn't get rescheduled, what case assignments were trustworthy, and so with in order to account for add-on cases and last-minute changes for if residents were swapping in a case. And so we the version that worked best for this was basically to build an inclusive kind of editable platform. So all the residents and the staff could at any time make quick corrections to it, either during the case or after a case, and use this to make their own case assignments in order to help organize which residents were going to work on which case. And this way you can bring the responsibility of the quality of the data to the people who actually care about it most and who need it for their own credit and their own scheduling and education purposes. So this is a view of what it looks like on the computer screen. The patient information has been scrubbed out for this demo, but it's basically a flavor here of all of the cases. In here, anybody can edit it and change any information if you have the right data permissions. And you can change the procedures as you get more information. You can click on staff or residents in order to see what level they're at and the details and make any quick changes there. And we built this as a way to help put the power back in the residents' hands so that they could use it in order to make their own lives easier. Okay, and so as Ruchi was mentioning with the change function, kind of the magic formula that we happen upon by trial and error is if you're asking for a minute of a really busy person's time, you have to figure out how to save them 2 minutes elsewhere. And so what we try to do to encourage more participation is every time we have a form anywhere, try to make it smart so that you have appropriate suggestions automatically appearing and help auto fill out the form as much as possible with the confirmation at the end so that the information is correct. So here, for example, two small pieces that you can see is if you're adding a case or editing it based on what kind of case it is, the appropriate residents and staff members suggestions show up there, so you could just you can agree to the suggestions or do a new search and change it if something unexpected is happening. And the same thing with the type of procedures. Okay. And then what I'll talk about is another kind of interesting, quick informatics aside is that, as you can imagine, just using a designed data API is a big enough project, if there's an HL7 data feed or a FHIR data feed. But for these kind of multi-institutional projects, most of the time we don't have that luxury. You have to get more flexible about how you accept input data. And so a lot of times the data that we need to integrate are old printouts or even handwritten notes and from all sorts of various silos that we're always surprised to find out exist here and there across computers in filing cabinets. So for example, we have to use some image processing in order to just get some of these printed data standardized and inputted. So here's an example of having a low resolution text that we use some image processing algorithms on to clean up the characters and then use a convolutional neural network to do optical character recognition to figure out what letters and what words those actually are before we can import it into a digital format. Additionally, there's all sorts of other interesting image processing work that needs to be done up front, such as removing artifacts from various forms that don't contribute anything to the information, lines and other parts of the form. And also there are even screenshots that need to be assembled, sometimes even from a resident holding up a phone if there's really no other way to get the data that they need to integrate. So taking all those partial screenshots, doing automated panorama stitching and repositioning to piece all those together like a big puzzle, and then do the full the optical character recognition on that form. So this is kind of the unsexy part of the data integration, but it's really allowed a lot of these projects to come together faster than a official API can be built for them. Okay, then case logging.
All right. So now that we have the operative schedule that's imported into the platform, the residents can use it, is going into the case logging. So for the case logging, we're trying to connect to the ACGME, American College of Surgery, and the Mastery of Breast Surgery. So case logging has always been a problem for residents, because residents tend to keep a record, a notebook, stickers somewhere, a bag of stickers, I'm not kidding, Excel spreadsheets, and they lose that information. But that information is actually the base information for the policies we make on how many cases are needed for graduation. So the accuracy of that and having attrition and lost cases has significant impact. And when we talk to the residents, and even from when I was a resident and understanding the workflow, the main issue is that in ACGME, you have to manually enter in all the information again. But you're like, well, the information exists in the EHR, why can I not get it over? And it's such a simple conceptual problem, fraught with a lot of like real life issue of, the hospital, it's hard to get a live feed of the data. APIs don't exist on both sides. Hospitals are very protective over that information. So we're depending on residents to log that information. So we decided that we would find a way to build an interface, working with a hospital, creating this HIPAA compliant platform that actually pulls in the operative information and puts it into the form and asks the resident to only work on the CPT code. So what we had to do, because APIs don't exist between for ACGME, American College of Surgery, or Mastery of Breast Surgery, any of these, is actually construct our own pseudo APIs that connect the platform to those to allow for the information logging. What this highlights is that in medicine and surgery, and especially in surgical education, we have not advanced as far as some of the other fields have with APIs for data sharing. And it has a bigger impact than we probably recognize. And what we're learning and measuring is actually the scale of the impact, and why we're hoping over time that these databases and organizations will open up APIs to make information sharing more seamless between the hospital and their databases. So an example of what we've discovered, because we've helped residents log over 50,000 cases, is the scale of the problem. We just submitted this to the American College of Surgery, so it's new data. We have residents that do their case assignments within the platform. We know what cases the residents are logging. So we've actually been able to show that based on two truth-based databases, 30% of cases go unlogged. So a third of cases are unaccounted for. That is a huge impact on what our understanding is of what residents are actually doing in the operating room and how they're training. By having the information pulled in so they don't have to enter it, we weren't able to decrease it down to 0, but it was down to 10%. So there's still a portion of it that we can't fix or reconcile, because that's probably a human behavior part of it. But 20% of it is a workflow issue of data reentry, redundant work on the side of the user, and really a failing on our part of not reusing existing data because of the limitations by siloing information. By making the information already exist there, surgeons are able to log their cases, in 10 seconds or so. So by improving the workflow down to when, 10 seconds to log a case, we can get people to log more cases, which means they're more likely to log the cases instead of having these very fragmented experiences. And, if it takes you 2 minutes to log a case, you're not likely to go through 50 cases and log them. But if it takes you 10 seconds, you'll log more of them. And this is just, it's the fact that we really wanted to understand the workflow and what the hiccups are and to build to that. Most of them log the same day because it fits in at the end of doing the case. Because you're sitting at the computer or you're on your phone or something and you get an alert like, oh, did you do a case? And you're able to log it. And importantly, we're able to help residents log their cases. This is data that we had presented at the American College of Surgery. And the lag between when they do the operation and when they log it is reduced down to 2 to 3 days compared to previously like a week or up to 17 days. And sometimes if the residents are really bad at logging, it would go up to 80 days. And you can understand that at 80 days those people probably have lost a lot of their cases. And then this is very interesting because this is where we're looking at we're trying to stratify the behavior of the people who are logging their cases. So, if they're logging directly into ACGME where they have to manually type in all the information, it was almost a 50-50 split. Early loggers and late loggers. Early loggers log within 70 days, late loggers log after 70 days. But by pulling in that information of the operative schedule without them having to enter it, we're able to convert 20% of late loggers into early loggers. Those are the people who benefit from freeing up data and integrating it. What we just submitted in a manuscript is actually looking at how many cases residents log a week, and this was done across 3 institutions. So when residents have to log, manually enter in their information into ACGME, they log about 1.5 cases a week. When we had our platform as an intervention, where we pulled in the operative schedule and we used our machine learning driven CPT code search, they logged 4.5 cases a week. And then we actually did a test intervention where we didn't enter in the operative schedule. We just had the, function an smart electronic notebook with a smart CPT search, just to see what is the impact, the true impact of entering data from the operative schedule. And the case logging dropped using the platform. Residents prefer to just use ACGME because they have to manually enter in the information anyways. And then when we resumed it, it returned back to the same level. So it's sustained. What we know is having to enter in redundant information leads to problems. Residents just don't log cases and they don't go anywhere else. They don't go into ACGME either because we didn't see a symmetric increase in the ACGME direct case logging. And then by understanding what cases residents are doing by using their case logs, we have built out Markov models to predict how many cases a resident will do. Before the COVID-19 pandemic, this was more of an esoteric research thing for us because we're very interested in understanding how can we change how many of a certain type of operation residents are doing. But this is becoming more relevant because there was a decrease in the number of elective cases. And the American Board of Surgery actually just a few weeks ago put out a hardship policy allowing residents who have done 20% less cases for graduation. But this will become relevant when we're trying to understand, these junior residents that are going to be ready to graduate. How many cases can we predict that they will be doing if we continue on the same sort of up and down trend of, having elective cases started and having them go down and go back and forth? So the next phase that we're looking at is the evaluations. So if you kind of think back to that slide, and I'm sorry I didn't put it in there, like the sandwich of all the layers and how we're reusing information. Kind of just to recap from the beginning. OR schedule is in there. That's the base information for case logging. That includes what operation a resident did with their faculty member. So we want people to do evaluations at the end of the operation. We just built something and we thought like, okay, what if we just push a reminder to the faculty members? We automate that process. Can we get more evaluations completed? Because evaluations, to provide some background, a resident tends to get probably about 10 operative evaluations a year. They do about 200 to 300, if not more, operations a year. So they get barely any operative evaluations. So this is a big problem, but we need to know how they're training. So we wanted to see what happens if you just push a reminder, because we have the information. We embedded multiple types of evaluations, and in surgery, there are evaluations that are specific to an operation. There are evaluations, just general evaluations. And as we're always looking to, like, we don't want to frustrate the faculty members, because we want them to do these evaluations, and we know that they tend to not like to do them because it's more time, is we cannot have the wrong evaluation show up for the wrong operation. So we actually built in our own mapping that exists between the description of the evaluations and the human readable description of an operation. And that's actually more variable than you would anticipate. So for a laparoscopic cholecystectomy, there are approximately 15 ways in which that's booked and described as people schedule an operation. So we've built this very complex mapping that we had to create on our own to allow the right evaluations to show up for the right operations in an automated fashion. This is the evaluation life cycle. So we estimated, 5 o'clock, generally people are done with their cases, that the platform in an automated way will send out a reminder. The attending can get it on their phone, in their email. They just have to click a link, because again, we want to make this easy for them to do. And they quickly submit this eval. That information is automatically pushed to the resident, because residents want to know how they're performing and they want their feedback quickly. It goes into the attending's profile, and then it goes to the program director also. So by having that automated push, having it immediately available is a value added for the residents and for the attendings and the program directors. And again, we want people to keep sharing that information. We want to keep gathering information on how we're training residents. So it's important that we understand what motivates them to keep participating. And what we're able to do is build out Bayesian-directed learning curves. So this is another aspect of our research, is actually identifying where someone is on the learning curve. Now, to build learning curves, you can't do that off of 10 evaluations that are not specific to an operation. We have to do that. We need multiple evaluations for a certain type of operation. And we're able to identify where a resident is on their learning curve. Most learning curves are sigmoidal. And a resident that's at the steep part of the learning curve, where they're just starting to get it, having this information can help a program director or a chief resident who's assigning the cases to know that, Ruchi would benefit from doing 5 more of these operations, because then she may reach that asymptotic phase of learning where we won't have the skill decrement, that she will have truly achieved competency. But unless we map this information out, our current way of doing this is by gestalt, by the faculty member saying, I think she's starting to get it, see if you can do a couple of cases with me, or based on case numbers. But again, if the case numbers aren't accurate, how do we know? We've just been kind of making it up, honestly. We're able to find this by having this workflow directed, automated push of the evaluations. Faculty members, could do them pretty quickly. And they usually did them right after the operation, compared to if they were going to get an email reminder from another system like MedHub. And that was, we think that's because they have to log into another platform that's purely for evaluations. By having a one-stop shop gets people to do more things by reusing the information. This is information, data that we had presented 2 years ago, in that the lag time for getting the evaluations when it was in a centralized platform was like a day, compared to 36 days, plus or minus, or really plus 30 days. Sorry, I'll pass it back to Jonathan for targeted.
Okay, thank you. So these learning curves that Ruchi was describing are really interesting for lots of reasons. One of the things that we're thinking about is helping to give very measurable, actionable tools to the program director to try different things to see what helps their residents learn better and learn faster on fewer cases, and how to optimize the case assignments and learning experience. So one of those one of those main intervention tactics is targeted education. So the idea here is that we're trying to make it much easier, lower the energy barrier for a resident to read up on a case and to prepare for a case. Because just most of the time, after a very busy day in the hospital, they come home wiped, they just want to crash, and it's very difficult to actually get into that study self-improvement mindset to start working, to start preparing for cases. And it's especially difficult during the day in the hospital when there's a million demands on your time. So we were thinking, if we could help push the right content in a nice, concise manner to the right people at the right time, hopefully we would see the shape of the learning curve change so that the residents could actually learn faster on fewer cases. And that would help them achieve a greater level of competency. So this is an active area of research right now that we're just starting. Okay, so the easiest way we could think of is pushing it to the residents' phones as recommendations, and also just having an easy click right from the schedule. So if you're a resident, let's say you have a lab chole coming up, all you need to do is click on it and you can see a video showing the technique, or maybe a anatomical diagram illustration so you can remember the relevant parts of the anatomy, or maybe a textbook chapter if you need to dive in, if you have a few more minutes before your case to review. Okay, so to do that, as you can imagine, there's a lot of background data organization work that you need to not only know what educational content are available, but how relevant each one is to each kind of procedure, and what is appropriate for which resident for which case. So we're doing this in a two-pronged manner, a manual and a semi-automated way. Manual way is luckily a lot of the teaching faculty and even some residents have already assembled a very high quality bank of papers, their favorite papers that they like to read, or at least their favorite textbooks. So we've gone through and we're working with them to help get a curated list of the content I think is the most helpful for each case type. And then in parallel to that, we're looking at a semi-automated way to crawl through relevant journals and relevant textbooks to piece out the important pieces of educational content so that we can start tagging them and having them available for recommendations. So here you can see it's looking at different pieces of a journal article, and now we need to figure out what each piece is.
Sounds like we may have one of our usual internet hiccups. Are other people able to hear me?
Yes.
Yes, we can hear you.
Okay. Well, hopefully they'll come back. We'll give it a minute or so.
Dr. Hirsch, is there any way to ask them if one of them can log in on their phone?
Yeah, we can.
For audio purposes only.
Yeah, let me. I'll send a message. Oh,
Oh, okay.
Now we're
You're
back.
back.
You're
Okay,
back.
good. Sorry,
Okay.
we're not sure what happened.
That's
Are
technology
you
for you.
guys? Are you guys at OHSU?
Yeah.
Yeah.
Oh, really? Yeah, it's
Yeah.
the university is supposed to have such great bandwidth.
I know. Sorry.
Anyways,
anything
we lost you about a minute ago, maybe
Okay.
a little bit of that.
Share the other screen.
I don't know how much more you have to go.
We're at the last slide.
Okay, good, because I think probably people want to ask some questions.
Yes.
Sure.
Where did
Yeah.
our presentation go?
Just drag it. Yeah, it's
It's the other. It's not that.
okay.
And, sorry, we closed everything out because we didn't know if it was us. That's one of the slides.
Okay. So. Okay, thank you.
Maybe
Sorry about that. Okay. Maybe we can just wrap it up and ask questions too.
Yeah, I think we were pretty much at the end. Sorry.
So anyway, I guess just to give a quick recap of it, we're using these models to try to figure out which content to push to the resident at the right time, and then we're measuring whether they learn faster by reading the material.
And then, sorry, last 30 seconds in closing. Training residents is hard. Reusing information has a huge impact. Paying attention to workflow is very important. And with a large scale system, we can kind of find questions and solve them, or try to work on solving them, iterating on solutions at the same time. And surgical education can be more of a data science, maybe more nerdy than most surgeons would want, but can be if wanted. Thank you.
Yeah, well, that's great. I just want to make a comment and then ask a quick question. And being someone from an internal medicine background, I won't drag out my surgeon jokes about data and knowledge. But I have actually come to learn that surgeons are actually very data driven. I think you demonstrate some cardinal principles of informatics that, if you make things easy for people to put data in, and if you provide them usefulness, when you get the data out, you get a more engaged audience. I think that's true with everything related to data in healthcare and medicine. I'm curious, I don't want to take all the question time, but what you see as kind of the major research questions that you want to answer going forward. And I think yeah.
One of the biggest is the learning curves, is actually using the case components and identifying commonality across operations, and identifying how we can train people better by figuring out how components match across operations. That's one of the biggest. And I think that's actually, there's a lot of work that's happening in that, and it will really change how we think about competency-based education. And I don't think it's possible to actually do that without informatics and data science driving it, because the information becomes too granular and too hard to manage by a single person, which is why I think we haven't achieved it at this point.
Great. There's a question and comment in the chat box from Eric Wecker, one of our clinical informatics fellows.
Yes.
Who was a bad logger in his residency.
See, everyone knows it. Okay. Let's see. I'll just read this. In my residency, I qualified as one of the bad loggers, family medicine residency. My QI project for residency was to generate a report from hospital EHR and process in such a way that was suitable to use for ACGME and make this reusable for all the residents. He accomplished his goal. Required periodic running of a report and processing with an Excel spreadsheet. Small amount of time. We wish I had more. So yeah, I think it's, it's a problem, as Eric points out, that exists for everyone. And, one of the big things is that it's hard for hospitals to share the information. I mean, really, it takes us months to a year, to establish that relationship, because it doesn't necessarily exist. But educational informatics, especially in medical and surgical education, I think is a under-researched, resourced area, but has a lot of impact on how we train physicians.
Great. Any other questions or comments? I see someone waving. You want to unmute and ask?
Yeah, Dr. Hurst. So for full disclosure, I'm a nurse practitioner that works under Dr. Thanawala, so she's my boss. So I've got a bias. Dr. Thanawala, Jonathan, thank you so much. I'm grateful for this, and I'm very grateful that you both are at OHSU. Two particular questions. On many of the slides, you had identified, or you had mentioned that the relationship between the platform and, for example, ACGME and the ACS is bidirectional, but the arrows were only going one direction. So does the ACGME have access to the platform in order to just evaluate, or even in rare circumstances, manipulate that? They access it. Second question, not sort of related. There was a slide later in the presentation that showed two pie graphs, and you showed the relationship between late loggers and early loggers. And you had mentioned that you set the time for early loggers as 70 days.
Sorry, 7 days.
So yeah, it's supposed to be a week.
Sorry. Okay, 7 days. Okay, thank you. That answers that question. So just the first question.
Yes. So the bidirectionality is actually not in that ACGME, can interrogate the data within the platform. It's more that we reconcile the information. So there's a possibility of, the classic database error of not having a unifying key between a common key between, two. So if a resident uses the platform to log the case, and then they go into ACGME and they erroneously log the case, we are able to bidirectionally, query that information and correct for it to reconcile. So that's more the bidirectionality of it.
Well, great. We're just about at the hour. I enjoyed your presentation. I'm sure others did as well. And like you said at the beginning, if any students or fellows have an interest in this kind of work, they should reach out to you and see what opportunities may exist. So good. Thank you for presenting, and we'll look forward to seeing you around campus at some point.
Great.
And I'll be seeing the fellows shortly in their meeting.